Thank you. So it's a question for Carlo Risuto about the socio-economic impact you talked about. And in the case of something like ELI, you are building a major research infrastructure in 3 countries. And according to your definition, you'll grant access to anyone based on excellence. And they're already building technology parks around it, but how will these countries foresee their gains in terms of research and innovation for their own communities if you open access to everyone in the world? So it seems like they could be building something that is very large and operating a very expensive infrastructure to then just provide the services to someone else.
Thank you. Now, there are other examples in normal life that I normally use when I have to meet politicians, because it's very difficult to stay on the level of research only. I mean, there are other infrastructures that are built, very expensive ones, and open for free to the users. These are the Olympic stadiums, for example. There are other infrastructures that are even given to the best users, paying the users. These are the Formula One cars. You want to have the best users of some infrastructures to make sure that these users bring to the infrastructures their know-how. So these infrastructures are collectors of the know-how and the knowledge of the users that you attract. It's like a fishing net. This know-how can be transferred, and you have to organize the territory around to capture the know-how, to capture the knowledge, to capture the impact, the education, the training, the technologies that these people are bringing for free, but not for free, because they bring in values, and use these values locally. Typically, if you measure on existing infrastructures what has been happening in the past, you take CERN, but you take also synchrotrons or big neutron centers or big research centers like EMBL in Germany. The return in the local territory is, the constant return in the local territory is of the order of 70% of the operation cost continuously, day by day. So not bad. I mean, if you have the return, the operation cost is 10% of the investment. So if you take 70% of 10% is 7% return, yearly return. And then this is the direct return, directly due to the fact that people spend locally, or you have customers, you have industries coming. Then you have the indirect return, attraction of industries, new jobs, new enterprises coming, and this normally comes to a factor 3 of the local expenditure. Then if you see also the wider aspect of new technologies, okay, take the case of the World Wide Web of CERN, which was just invented by 2 physicists that wanted to communicate to each other. The overall impact is much, much larger than the investment that was made. But you have to argue continuously on this. Yes? Sorry.
I understand the argument.
I
understand the argument, and I've read the socioeconomic impact report from OECD about CERN or XFEL you were talking about, or ESS or whatever. These are not built in Romania or in Hungary or in any of these countries. So the capacity to organize innovation around a large research infrastructure might be different, and I wonder how you factor that in to your socioeconomic impact models.
No, definitely. What is very good is that Romania, Czech Republic, and Hungary have built the nets around, have started to build the nets around. So they are dealing with the absorptivity of the territory, trying to increase it. and that they are doing a good job. I mean, as always, the timing on which you see the effect is of the order of 10 to 20 years. I mean, if you take Sophia Antipolis, the French had to invest there for 25 years before getting a return. But this is happening. I have the case of the synchrotron in Trieste, which, by the way, I was chairing, which was in the middle of nowhere in a bottleneck, because there was the Iron Curtain on the other side. So it never started really giving a return until the Berlin Wall fell and the border opened. So you have to have also, let's say, communication network, mobility around the place to help you really getting to this result.
Brecht van Lerbergen from the Biobase Europe pilot plant. Also a question to Mr. Carlo Rizzuto. Maybe I can do it without. Okay. I try to do it without. We're involved in a Horizon 2020 project in InfraDev, which is addressing your question, in preparation of an ESFRI project started this year, 2016, and we hope to target the ESFRI roadmap of 2018. How realistic is that?
Well, I don't know what is the project, so I should.
I will rephrase. I have done the exercise for the ESFRI roadmap 2016. I started in 2014, trying to find out how it works. It took me a year to find out how ESFRI works. Then I got in contact, I think, with the right people at our governmental level, and then we got a new government, and they changed the whole system. So now I'm lost again. So
it's what I was telling you. I think, I mean, in these projects in general, projects about research infrastructures, you have to have an excellent idea of the scientific part, but that is not enough. The bottleneck is to find the right people to make it, and to make it working. And this is what we have not very much in Europe, in the overall Europe. Because the academia in Europe is too much public linked, too little mobility in all countries.
The hardest part for us was, you have to lobby in multiple countries.
Of course.
So that's the biggest part.
Yeah.
You have to align all these different. So you
well,
have three partners now.
My father was from Sicily, so. And my mother from Holland.
Okay.